Okay, so Algebra 2, we're in 2.4, Solving Formulas is the title of this. So if you skim through the notes or look at the board, you're going to see there's a ton of letters. So there's good news, bad news to this. Okay, I think it's more good news, but maybe you won't agree with me, I don't know. If you're freaked out by the fact there's a ton of letters instead of one variable, that's like today's mental obstacle, the hurdle for you to get over is there's a lot of letters and it's okay. Okay, so breathe a deep breath. Don't worry about the fact there's a lot of letters, because in fact that's going to make this process easier. We're still solving equations in the same way. Still the equal sign is here, still the equation's like a scale. Still doing opposites. Still whatever you do to one side, you do the same to the other, all that kind of stuff. What goes out the window is checking, and what goes out the window is all the arithmetic. Okay, so here's the good news. If you've solved equations and you've had issues where you're supposed to add 10 and you're adding 10, and then you just do the math wrong because of positive signs or negative signs or rules with negatives and positives or fractions or decimals or whatever, if you make any math errors as you're solving, today the math errors are out the window because there are not really any numbers to do arithmetic errors with them, right? So in that sense, this is easier than the stuff we've been doing. But you do have to get over the first mental hurdle of, oh boy, there's a lot of letters here, okay? So if you think you have confidence you could do this stuff already, just pause my video and start doing stuff and then check it and see if you're right. I'm a big encourager, again, of the more you're engaged in doing the work at home, the more you're going to learn this than if you just watch me do it. Watching is better than nothing, but doing at home is better than watching me do it. So here's the kind of thing we're doing. They're going to give you a formula with lots of letters. Some of these are real formulas for real things. Like this is to do the circumference of a circle. That's the volume of a box, area of a triangle. No idea what that one is. This is just a made up silly one. I don't think this is based on anything in particular. But some of these are real formulas for real situations. Some of them they just threw a bunch of letters together. But they'll give you something with several variables, and they'll tell you which variable they want you to solve for. And they're saying, hey, we want the C alone. So if you want to get the C alone in this one, you're going to have to see what's happening to the C, no pun intended. So since C is adding B, what you'd have to do the opposite, go ahead and subtract B. I don't care if you show work or not. So you're subtracting B on this side to get the C alone. If you try to subtract B on this side, you can't really do A minus B. Those aren't like terms. So your answer is simply A minus B. I think that's easier than if there were numbers there, because if these had been all numbers, you'd have had to actually do the math and solve it out, and maybe the math was two numbers you didn't really want to subtract, like two crazy big fractions or something. If you think you got the hang of that now, go ahead and take on a few. Pause me while you do that and then come back. But here, if I want to get the D alone, I would have to divide by the pi. This is multiplying, so if I want to get this out of there so the D is alone, I would do the opposite. This is multiplying, I'm going to divide. So if I divide by pi, that's gone. If I divide this side by pi, I'm just going to make that look like a fraction, where C is divided by pi. And on we go. For this, we're trying to get the L alone. So W and H both need to get out of there. For me to get the L alone and get the W and the H both out of there, I'm just going to divide. They're multiplying, so I'll divide. Dividing would get rid of these. Dividing is going to make the fraction bar. Dividing will always take the things we're trying to eliminate and move them downstairs. So W and H would go to the bottom. The V would just continue to sit on the top. For this, if we're trying to solve for B, we've got two things to do. I'll deal with the fraction first, because that's probably the worst part of this. If I want to get rid of this fraction, the fraction's multiplying, I'll have to divide the fraction. When I divide a fraction, I flip it. So if I flip a half, it turns into being 2 over 1, or just simply 2. So to get rid of this, I'm dividing by a half. That's multiplying by 2. So over here, I'm going to multiply by 2. And the B and the H are both still sitting there. All I did was get rid of the half. To get the b completely alone, I need now to get rid of the h. Again, h is multiplied, all have to divide. When I divide its fraction, the thing I'm dividing by always goes to the bottom. The other stuff from the other side of the equals can just sit on the top. So we get that one. For this, I'm going after the c. If we had people in the room and I said, hey, what do you suggest we start with? Some people would probably suggest to distribute. And based on the style of how this looks, I understand that, but I would not do that. If you distribute the 2/3, you have, instead of one fraction making a little bit of clutter, you'd have fractions cluttering out multiple different things. And you'd rather not have a lot of fraction clutter. So the first thing I would do here is, instead of distributing and making more fraction clutter, I'd get the fraction out of there. Okay? Right now, this fraction is trying to multiply. Distributing is a type of multiply. So to get rid of this fraction, I do the opposite. I'll divide it. And again, for the second time today, when I divide fractions, I flip them. So to get this out of there, I would end up with a flipped version of that fraction going over with the b. And at that moment, with the fraction gone, I'd be left with c minus 5, and the parentheses no longer have any real meaning or value to us. To get the c completely alone, I just have to get the 5 out of there. Since that's subtracting, we'll do the opposite as always. We look to add. The 3 over 2b needs to add 5. And we're good on that. Over to this one, a little bit bigger. Biggest one probably so far. If we're trying to get the m alone, we have a couple things to do here. There is a multiplying by 3, so we're going to have to divide by 3. There's also some adding going on, so we're going to have to do some subtracting. As always, we'll add or subtract beginning before we worry about multiply or divide as we solve equations, because the order of operations is opposite. So to get rid of the adding 2r, I'd want to subtract 2r. If I go ahead and subtract 2r on this side, I have to do that on the other side. The h has to subtract 2r. And I can't really do any of the math. I'm just going to write h minus 2r. At which point the 3m is left remaining. To get the m completely alone, I've got to deal with the 3. 3 wants to multiply, I'll have to divide. Dividing is fraction bar time. The 3 goes to the bottom. Whatever was with our variable that we're trying to eliminate, that's going to go to the bottom. This h minus 2r could go to the top. If you want to do parentheses, you can, but remember there's just rulings in math. There's a lot of invisible stuff here around the board. Parentheses around the whole top, they're there invisibly whether you write them or not. Just like this had a 1, just like this has a decimal point, just like 7 is over 1, those things are there. They're just not written. They're invisibly there. I wouldn't personally write the parentheses. They're not wrong, but I wouldn't write those any more than I would put a first power on this. I don't need it. It's there whether I write it or don't write it. This last one's a little bit crazy. Well, I forgot to say which letter we're solving for. I'm presuming it's for Q. Sorry if that slows anybody down. So if you haven't taken this one on yet, you could pause it. We're trying to solve for Q, and this is different because Q is in more than one location. There's a couple Q's. So for us to solve for Q's is going to take a different tactic than anything else we've seen, but it is a tactic that we did this year talk about, but more so you've talked about this other years. If we were in person, somebody always every year is able to come up with this tactic eventually, but sometimes we're staring at each other for a couple minutes. Sometimes it's one of those moments where I end up just sort of sitting down and waiting while people stew and just yell ideas out there. But if you want to pause to see if you can be the one that would have come up with that answer this year if we were in person, and then resume with me in a minute. The trick for this, the first hint I'll drop, if we were having trouble coming up with an answer, is our first goal is to go from having 2 Q's to having 1 Q. There's only one correct way that we can go from having 2 Q's to having 1 Q in doing this problem. If you still don't know how to do it, well, for that hint, maybe pause and think if you want to do some thinking today. But if we haven't come up with it in the past, that's usually the hint that gets somebody to go, oh, I know a way we can get from having a couple Q's to only having one Q. And that is to do this. Zoop. Okay. We're going to leave the T alone. And we can go from having two Q's to having a single Q by doing a math process that's called something. Maybe try to retrieve what that's called for a minute. That is called factoring, or more commonly called factoring a GCF. It's the opposite of distributing in this case. There's a lot of kinds of factoring, but this is like an anti-distributing kind of move. So if we factor a Q off of this, the Y is left, the I is left, and this has one of those invisible ones that we just talked about, that when we take the Q off, there is still an invisible one that's going to be left. So that's our first step towards success. Having two Q's is bad, having a single Q is good, factoring off a Q is what accomplishes that job. Then we want to get the Q completely alone, and we're one step away from answer city. See if you can finish from there, pause it, do it, see if you get it right. To finish this, since Q is multiplying right now, parentheses mean is trying to multiply, we're going to have to divide. And as always, divide means fraction bar. The T that was alone before stays on the top, and this whole thing, this 1 plus IY, is going to go to the bottom. If you want to bring the parentheses along, again, you could, but that's the discussion we just had a second ago. The parentheses invisibly are there, whether you write them or don't write them, so it doesn't matter at all if you write them. 72 is where this homework is. It's going 1 to 24. And then in 29 and 30, they ask you a couple what-if questions that involve something we haven't done this year, but you've done before. Again, everything in math has an opposite. Whatever you do to one side, you do to the other. So everything we've done has either been adding to make you subtract, multiply to make you divide, or vice versa. What they're asking you about in number 22 is, if squaring is involved, how do you undo that? Because squaring has an opposite. And in 30, they're asking you if cubing were involved, how you'd manage that? Because cubing has an opposite. See if you can come up with those without me telling you. If you can't come up with it yourself, Google it maybe, I don't know, or join a Zoom meeting and let me know, hey, I don't get what you're talking about, help me with 29 and 30. We can Zoom and talk about it, but 29, 30, they're talking about some what-ifs of doing some opposites that haven't factored into Algebra 2 this year yet, but they've been done before. That's it. See you guys.